Okay, question 2, we need to get the matrix product. So matrix product could be defined, could be undefined. The first thing, we have to make sure the matrix product is defined before do the calculation, right? To check the matrix product, whether it's defined or not, you just need to write down the dimensions of both matrix. The first matrix is 2 by 3, right? Sorry, 2 by 2, right? It's a 2 by 2 matrix. And the second matrix A is a 3 by 2 matrix. Okay, if we can calculate the matrix multiplication, right, we can only do that if this number is equal to this number. Okay, we can only do the matrix multiplication if the number of columns of the first matrix is equal to the number of rows of the second matrix. Right here, this is not the case. 2 is not equal to 3. Right? If these two numbers are different, then we cannot do this matrix multiplication. Okay, which means we conclude that our conclusion is that it is undefined. Right? So let's see an example where it is defined. Okay, in part B, it's B times C. So what is matrix C? C is a 2 by 3 matrix. It has 2 rows, it has 3 columns. First row 1, 4, 2. Second row 3, 1, 5. So now let's write down the number of rows of B, right? Rows and columns. So B has 2 rows, it has 2 columns. C has 2 rows, and C has 3 columns. Okay, so now you see the number of columns of the first matrix is equal to the number of rows of the second matrix. So now we can do the matrix multiplication. Okay, let's copy it. We know we can do it now, but what's the result? Right? What's the result? The result is a matrix. Then what is the dimension of this matrix? Okay, it is this. Right? What's the dimension of the matrix? It's going to be the number of rows from the first matrix and the number of columns from the second matrix. So here, the number of rows of the first matrix is 2. Okay, so the result is going to have 2 rows, and the second matrix number of columns is 3, so the result should have 3 columns. So we know we are expecting a 2 by 3 matrix. Okay. Then the third step is what are all the entries? Okay, what are all the entries? So for example, this first entry, right, we call it A11, for example. Right, this is a 1-1 entry because it's on the first row, it's on the first column. Okay, so how do we get A11? A11 is exactly, okay, so for this one is from which row of the first matrix? Because it's 1, so it's from the first row of the first matrix. Then this one is from which row, which column of the second matrix? Okay, it is from this column of the second matrix. So the result is, right, the first row of the first matrix times the second column, sorry, the first column of the second matrix. Okay, then this product is simply first number times first number plus second number times second number. Sorry, here's a typo, right? It's 4 times 1. Right? It's 4 times first number times first number. It's 4 times 1. So the result is 1. Okay, so here the result, the product 1, 1 entry is 1. So you're going to do the same for all 6 different entries. Let's do it one more time. For example, A12. Okay, A12 is here. Then what is A12? A12 is the first, right? Because from this one, you know, it's the first row. And from the 2, you know, it's the second column. So it's the first row of the first matrix times the second column of the second matrix. So it's 4 times 4 plus -1 times 1. Okay, it's 15 here. So the 1, 2 entry is 15. Okay, let's do another one. For example, this entry is A22, right? A22 because it's second row, second column. It is A22. Then where is A22? How do you get A22? Same steps, okay? The first number is 2, so it's from the second row of the first matrix, and the second number is 2, so it's from the second column of the second matrix. Okay, so it is 0, 2 times 4, 1, which is the first number times first number plus second number times second number, which is 2. Okay, so you do the same thing for the rest of the problem, you'll get the result. Okay, you'll get the result. So this is a matrix product, matrix multiplication. Okay. Part C. Part C, we have something called the transpose. So it's D transpose times minus E transpose. So what is the transpose? D is a 3 by 3 matrix. First row 1, 5, 2, second row -1, 0, 1, third row 3, 2, 4. Okay. So if you transpose it, it's very simple. It's just here it's the first row, then you write it as the first column. Okay, so here the first row is 1, 5, 2. So that's why here the first column is 1, 5, 2. Similarly, the second row is -1, 0, 1. Then here the second column is -1, 0, 1. Right? Third row becomes the third column here. Okay, so that's how you get the transpose. Okay, this is the transpose of a square matrix. So, for example, what about the transpose of C? Okay, it's not asked in the question, but we can try it. So C, you can see it's not a square matrix. It is a 2 by 3 matrix. Okay. So then, if you transpose it, it's a similar idea. The first row becomes the first column. It is 1, 4, 2. Okay. The second row becomes the second column. It is 3, 1, 5. Okay, so this result is a 3 by 2 matrix. Okay. All right, back to the question C. Minus E. Right, E is okay, let's write it down here. Okay, let's write it down here. E is itself, it's also a 3 by 3 matrix. First row is 6, 1, 3. Second row, -1, 1, 2. Third row, 4, 1, 3. If you transpose it, again, first row becomes first column, right? 6, 1, 3. Second row becomes second column, and third row becomes third column. Okay, so D transpose minus E transpose. Okay, then for the matrix subtraction, it's very easy, right? It's just a number minus this number, it becomes the result. So 1 minus 6 is -5. Here, -1 minus -1, it is 0. Right here, 3 minus 4, it is -1. So do the same thing for every entry. Right? 5 minus 1 is 4, 0 minus 1 is -1, 2 minus 1 is 1, 2 minus 3 is -1, 1 minus 2 is -1, 4 minus 3 is 1. Okay, this is part C. Part D, D minus E's transpose. Okay, you can see these two are very similar, but the orders are different, right? Here, we first do individual transpose, and then we do the subtraction. Here, we first do the subtraction, then do the transpose. Okay, so first guess. I think they should give me the same answer. Okay, let's try it. So D minus E, right? D is here, minus E is here. So again, it's a first entry minus first entry. It's going to be, right? It's going to be so 1 minus 6 is -5, right? And then 1, 2 entry minus 1, 2 entry, 5 minus 1 is 4. Right? You do the same thing for every entry. Here, -1, here 0, here -1, here -1, -1, 1, 1. Okay, then you transpose it. Okay. And when you transpose it, you'll see something. First row becomes first column, second row becomes second column, third row becomes third column, which is exactly same as in part C. Okay, so in general, it's always true. A minus B's transpose is equal to A transpose minus B transpose. Okay, again, one thing for the matrix subtraction, when you do A minus B or A plus B, right, you want to make sure A has the same dimension as B. Okay, only when A, B, they are of the same dimension, then you can do the matrix addition or subtraction. Otherwise, you can't do that. Okay, so part E. I think part E, it's a matrix product, and it's, I think I can leave it to you. It's D times E. So again, D is a 3 by 3 matrix, E is a 3 by 3 matrix. Right here, the number of columns of the first matrix is equal to the number of rows of the second matrix. So you can do it. Okay. Should copy it down. Then the results, the 1, 1 entry, right? For example, the 1, 1 entry is first row times first column. So it's, it's 1, 5, 2 times 6, -1, 4. Okay. Which is, okay, let's call it A11. The result is 1 times 6 plus 5 times -1 plus 2 times 4. So it's 14 minus 5, it is 9. Okay, then you do the same thing for all other 8 entries. Right, you will get your result. So part F, dA transpose, right? D times A transpose. So again, first you have to make sure we can do the matrix product. Okay, I think the convention is that we don't write this dot. D is a 3 by 3 matrix, A is a 3 by 2 matrix. Here, the number of columns of the first matrix is equal to the number of rows of the second matrix, so you can do this, right? You can do this, then just do it. Okay. I think this part is just a combination of two concepts we have learned. Right. First one is matrix product. Second one is a transpose. So D is, just copy it down. All right, and A is 3, 0, -1, 2, and 1, 1. Okay. And you first do the matrix product, then transpose. So if you do the matrix product, matrix multiplication, you should get a 3x2 matrix, which is this. Okay, then you transpose it, you get this result.